Okay, so now let's move on to section 3, which is discrete the expected value. So before we work on the problem, let me just give you a short review on expected value. Expected value of a random variable x is also called mean or mu. It's defined to be the sum of x times the probability mass function of x equal to xi. So that is when I ranging from guys xi times the probability of x equal to xi, and then from 1 to n, where 1 to n is the range of a random variable x. So for example, for problem 1 for problem 1a, so problem 1 is that we roll two fair four-sided die, and then we want x to be denoted to be the minimum of trial 1 and trial 2, and y denote to be the maximum of trial 1 and trial 2. Here T1 and T2 are just like a notation for the result, like trial 1 and trial 2, because we roll it twice. So if you want to calculate the expected value of x, all we need to do is to look at all the possible range of x, a random variable x, and then calculate the probability of at certain range. So we know that x can be what? X can be 1 or 2 or 3 or 4, because the maximum of any die is 4. This die is 4, and the minimum is 1. So expectation of x is just 1 times the probability of x equal to 1 plus 2 times the probability of x equal to 2 plus 3 times the probability of x equal to 3 plus 4 times the probability of x equal to 4. So now we need to just to calculate this for probability. So remember, for probability of x equal to 1, that means both die, there should be one die that is 1, and one die is from 1 or 2 or 3 or 4 or 5, or it's just up to 4, I think. Yeah, so that has to be the case. But remember, if we do 2 times 4, that is wrong, because that is when we count 1 and 1 twice. So we need to do minus 1 here. So 2 times 4 is because if we choose one die to be 1, the other die can be either 1 or 2 or 3 or 4. And we have 2 possibility to choose that die. And also we know that the total outcome is just 4 times 4 equal to 16, because each die has 4 possibilities. So the probability of x equals to 1 is 7 over 16. Also, you can apply the same logic on probability of x equal to 2 and 3 and 4. You can find that this is equal to 5 over 16. This is equal to 3 over 16. And this is equal to 1 over 16. So the expected value is just 1 times 7 over 16 plus 2 times 5 over 16 plus 3 times 3 over 16 plus 4 times 1 over 16, which is 30 over 16. So that's our expected value in this case. And then for part B, we want to find the expected value of y. And y is defined to be the maximum of 2 trials. Again, we are writing this as 1 times the probability of x equal to 1, or y equals to 1, plus 2 times the probability of y equals to 2, plus 3 times the probability of y equal to 3, plus 4 times the probability of y equals to 4. And what's the probability of y equal to 1? That means the maximum of That means the maximum of 2 rows has to be 1. So that's just 1/16 because there's only one example of 1, 1 that resulting of these 2 rows to make the maximum 1. And similarly, we can count y equals to 2, which is just 3/16 because the possible choices are 1, 2, 2, 1, and 2, 2. And the probability of y equal to 3 is just 5/16. Probability of y equal to 4 is just 7/16. So this formula is just equal to 1 times 1/16 plus 3/16 times 3 plus or 2 times this, and 3 times 5/16, 4 times 7/16. That's just 50/16. So that's part B. And for part C, we want to calculate the expected value of 2x plus 3y. Remember that the expected value expectation follows the linear transformation. So that means like the expectation of ax plus by equals to a times the expectation of x plus b times the expectation of y. So in this case, e of 2x plus 3y is just 2 times e of expectation x, 3 times the expectation of y. And we have already calculated the result of expected value of x and y. So we can just simply plug in the formula here, which resulting in 210/16. And then for problem D, we are finding the expected value of x, y. But remember, like this time, exy is not equal to expectation of x times expectation of y, because x, y are not independent in this case. Remember, so let's say the intuition that y, x, y are not independent, because like x is a minimum of 2 rows. If x itself is equal to 6, that tells us what? That tells us the outcome of these 2 trials has to be 6 and 6, or 4 and 4, because we are rolling a 4-sided die. So the maximum has to be 4 and 4, which also like lead us to like determine y. Y is the maximum of 2 row. So if we know that the x equal to 4, we know there's only one possible outcome, and we also know the value of y. So that means knowing of certain value of x can lead the result of y directly. So that means x, y are not independent. So instead, we are actually calculating this random variable x, y. So we make a table of random variable x, y and list all its possible value and gives the probability of all the random variable x and y. So x and y can be 1 or 2 or 3 or 4. That's just like for example, like 1 times 1, 1 times 2, 1 times 3, and 1 times 4. And we can do like 2 times 3 to get 6, 2 times 4 to get 8, 3 times 3 to get 9, 3 times 4 to get 12, and 4 times 4 to get 16. You can also like check these are like all the outcomes of x, y. And then what's the probability of 1? That's just 1/16. And similarly, I think we have done this example last time, so I'm not like going details on how do we get these probabilities. So each of the probabilities corresponded to sum of the outcome that comes from a random variable x and y's multiplication result. So all we need to do here is to multiply x1 with probability, because like remember, expected value of xy is just the summation of xy, xi times the probability of xy equal to xi I guess, for like I in the range of r xy. So you can also like treat z equal to xy and plug in the definition of z. So if we do the summation in this table, at last we will get the result of 100/16.